All right, so for those of you who are pretty good at knowing multiplication facts and being able to pull out factors of things that you are basically dividing from, then this pull out the perfect squares is going to be very good for you. It's also good for people who are good at memorizing what numbers are perfect squares. I am including a resource for you that will list out all of the perfect squares. I think for the answers that go from like 1 till about like 20 or so. So just using that as a reference chart even can really help you out. So let me show you how I could do this for a few of these different types of problems here. We have ones that are cube roots and we have ones that are square roots here. So why don't I start off with showing you how to do this. Let's just start with the square roots here. So let's say that I had the square root of 64. How would I use factorizations to find out what the square root of 64 is? This one's a perfect square. So even if you didn't know the factors here or the what perfect squares were, you could use factors to figure it out. So when I think of the numbers that go into 64, you think of it as 1 in 64. So that's not going to help you. You skip the 1. You start with the smallest prime number other than 1, which is 2. So it would be 2 times 32. Now, if I knew anything about perfect squares, I know neither of those is a perfect square. Now, 3 does not go into 64, but 4 does. 4 goes in this particular case, it's going to go in, I want to say 14 times. Yeah, 14 times. And then 5 doesn't go in, 6 does not go in, 7 doesn't, but 8 does, and it's 8 times 8. Now, if I was looking for the square root, you're basically asking yourself, since we know the index number here is a 2, what is the number that multiplies by itself 2 times in order to make 64? Well, when I look at this, I have 2 8s. So that would imply that this is actually 8 times 8. And when we find the answer of this, you're basically just going to be like, okay, well then I can pull out a number that groups in twice, something that multiplies by itself twice, and that goes on the outside of the radical. And anything that's left over stays on the inside. However, since there's nothing left over, 8 times 8 is 64, that makes the square root of 64 8. You can use the same method when we're looking at factors of 27. Now, for this particular factor, what you're going to do is, I like to do something called a factor ladder for this. And this would also help you with the other method of pulling out roots and square roots, which is something I'm going to show you in a different video. So what you would do here is a factor ladder. You're going to go ahead and write down the number 27. Make a little ladder, like a rung. Oopsie daisies. Draw. Make a ladder rung here. And you pull out the smallest prime number that goes into it other than 1. Now in this particular case, 1 is not going to be used, but 2 cannot go into 27, so you'd use 3, because 3 goes into 27. Now since we have 3 going into 27, we would then divide 3 into 27. 27 divided by 3 makes 9. And you would continue this process until you reach a prime number on the rung here. So 9, smallest prime number that goes into 9 other than 1 is 3. Again. And 9 divided by 3 makes, in this case, 3. Now since 3 is a prime number, you would stop. And then you would ask yourself, what number multiplied 3 times by itself makes 27? Well, when I look at this, I'll just draw the 3 this time there. I'm going to go 3 times 3 times 3. Because it's these numbers right here, the one that I picked out, the one that I picked out, and the one I'm left over with, that go into here. Now, since 3 is multiplying by itself 3 times in order to make 27, the number you are pulling out 3 times as noted in the index, would be 3. So the cube root of 27 is 3. So that's a basic way you can do it for perfect squares and perfect cubes, and whatever number you get in the index to find a perfect number, that's how that would work out. But as you know, with math, things don't always work out, even though things aren't always perfect, right? So I'm going to show you how to just simplify radicals using this same method. Now, when I look at this particular thing here, let's say I have the number 48, and I'm using a square root of 48. If I were to pull out the factors of 48, 2 goes in 24 times. Neither of those is a perfect square. 3 goes in 16 times. Now, because I know 3 was the next smallest prime number, if this is a perfect square, that's going to be the largest perfect square. It's going to match smallest to biggest. Smallest to biggest here. Second smallest, second biggest. So since this is the second biggest number, second biggest factor of 48, that means 16, since that is a perfect square, is the largest perfect square that goes into 48. So when I write this here, I've got what I need to find my answer. And here's how this is going to work. I get this here, going here, and I said this was 16 times 3. Now, since that is 16 times 3, here's how this is going to factor into the answer. You notice I have two different numbers here. It's not the same number, it's two different numbers. You are going to take the square root, find the square root, find the number that multiplies by itself to make this number 16. And of course you can use like radical charts for this in the class. This is not something you're going to be tested on. This is just review stuff. So when you look at this kind of thing, what I can see here is, since I'm doing square roots, this is basically like, okay, so 16. When I think of the number 16, I can make it 2 times 8, or I can make it 4 times 4. So that's like 4 times 4 times 3. So 16 as a larger number breaks down to 4 times 4. And essentially, I stick with the draw here. I'm just going to do this for the answer. This last part here will be the answer to this one. This is going to come out to equal, since 4 is the number that's grouped twice, since we're looking for something that's a square root 2 times, 4 goes on the outside. That's the number that is the root of 16, and 3 is the remainder, what's left over. So 4 root 3 is how you would simplify that. Now, when I look at a cube root of 54, it's a similar process, except for looking for a group of 3. Now, since the index, the number in here, is bigger than just 2, we're going to use the factor ladder method here. So I can go ahead and I'll draw 54 here. And what I'm going to do is draw a rung, and I'm going to pick the smallest number that goes into 54 other than 1, and that's a 2. And then I divide 54 by 2, and that's going to make the number 27. Now, looking back at my previous ladder, I already know that you can break down 27 like this, right? 3 times 3 times 3. So this becomes something like this. 3, the 9 is going to go here. Draw this thing here. And then 3 here. And one more rung of a 3. Because we basically just said 2 is the smallest number of 54. It makes 27 if I divide 54 by 2. Smallest number goes into 27 is 3. 27 divided by 3 is 9. Smallest number going to 9 is 3. 9 divided by 3 is 3. And we're left with prime numbers. So when I break down cube root of 54, this is going to come out to equal this. Here's my cube root. And this is going to be 2 times 3 times 3 times 3. And now when I'm doing a cube root to simplify, I'm trying to look for a number that pairs 3 times. So in order to pair a number 3 times, what number appears 3 times here? It's a 3. So with that, I'm going to draw 3 on the outside. I'll draw my radical symbol. I have to make sure that in my answer, I keep the index number right here. So there's still going to be a 3 there. And then I'm going to have the remainder on the inside, which is a 2. So 3 times the cube root of 2 is how that would read. In fact, why don't I... That's fine. So that's essentially how you would do these methods here. Now, interestingly, this actually goes over both methods that you could use for this. So if I'm really good with pulling out perfect squares, this here, oops, this here, and this one here are the pulling out the perfect squares method. If that's not something you feel comfortable with, or if you don't have a like a roots chart accessible to you, then you could always use the factor ladder method, which is this one and this one. And of course, you're always welcome to use a calculator to figure out the calculations for these guys. This is just showing you how to manually do this when you don't have a calculator by you, and if you can do just simple division and multiplication.